Alright, so the objective for today is that we're going to learn how energy is transformed from one type of energy to another, and it happens all the time. So your essential question is, how do different types of energy change into one another and cycle through Earth? So, when we looked at energy, we started talking about energy. We said that energy is basically the ability to do what? And there's a bunch of different types of energies which we'll talk about, but specifically you don't need to... The reason we're studying the different types of energy is not because you know all the different types, and that's it. It's because you're going to have to understand the transformation of one type of energy to another. So since you have to know the transformation or the changes, that's what transformation means. It changes. They transformers, they change, right? Okay. One meets the eye, right? Alright, so transformation just basically means that you're having the energy change from one type of energy to another one. Now, these notes go on page 149 of your notebook, and yes, they are core notes. So, what we need to realize is that when energy is used, it changes from one type of energy to another one. Because when it is used, remember, it doesn't disappear because of the law of conservation of energy. And what does the law of conservation of energy say, Ivan?
No energy can be created or destroyed, it can only be transferred.
Very good. Yes. Very good. So no energy can be created nor destroyed, it can only be transferred or it can be changed. And that's what happens. So when you're using energy, yes, you're using it, but what you're using it for is you're taking that energy and it's being changed into something completely, it's a different type of energy. So energy transformations are just looking at how that energy changes from one type of energy into another one, and it happens all the time. Okay? As I'm speaking to you, the mechanical energy that my vocal cords have because they're vibrating are making vibrations in the air, which causes sound. That sound travels through the air from between my mouth to your ears. Then when they get to your ears, that sound makes vibrations in your eardrum, which sends signals, electrical signals, to your brain, and it changes into information. So energy is changing all the time around you, every single second of your life, because we can't destroy it, we can't create it, so it has to change because we're using it. Now we're going to look at the different types of energies. So starting off with electrical energy. What is it?
Electricity.
Electricity. Basically, electricity is the movement of charges down, usually, a wire. So electrical energy is just the movement of charges, positive and negative charges down an electrical wire. Have you ever looked at a battery that doesn't have a positive side and negative side? Okay? It's because of those charges. Those charges are going from the positive to the negative side. That movement of charges through the wire is electricity. Okay? Now, when we think of electrical energy, anytime you see batteries, would you think that it's going to become electrical energy? Yeah? Wires, if you think of wires, does those carry electrical energy?
Yes.
Okay? A generator. Okay, if you were lucky enough to have one during the hurricane, what did you have that other people didn't have? Electricity. So, when we look at energy transformations and then we start talking about the test, if they talk about wires, it's electrical energy. If they talk about a generator, it's electrical energy. Okay? So anytime you see generator, immediately think electrical energy because that's what it's making. Okay? What ends up happening with that generator is, in the case of the hurricane, you put gasoline in there, and gasoline was chemical energy, when that gassing was being burned up, it was basically moving rotors inside of the generator, and that moving of rotor created electricity. How does it do that? Well, when you do this, what do you create? Friction. Now, if I do this a lot during the winter time and then I touch you, what happens? Static. Does it shock you? Or can it shock you? Yes. That's electricity. So, friction creates static. Static is it creates electricity, creates an electrical charge. That's how a generator works. Yes.
So it's like generator needs gas, right?
There are generators that need gas. Not
So
all
would
the
it be so a
generator
generator
needs gas.
with the gas? Would it be like a car that how does it transform the gas into the energy and it moves to make electricity?
It moves to make it electricity. So technically, it's a generator car. Have you ever seen the? Well, you've probably never seen it, but there's some handheld ones where you can just take it and just do this and it lights up. Have you seen those? There's lamps. There's flashlights that you crank it and you crank it and crank it and it lights up. That's what it's a generator. So a generator, all it does, it creates electricity. So please make sure that if you didn't know that that's what a generator did, you include that in your notes, because that's one of the things you're gonna see a lot of. You're gonna see the word generator, and immediately after you see the word generator, you think electrical energy, because that's what it does. Okay. All right. Then we come over to mechanical energy. Basically, mechanical energy is energy of anything that is moving. If there's water moving, it's mechanical energy. If there's air moving, it's mechanical energy. Any type of motion of one point to another is mechanical energy. If I'm running, it's mechanical energy. Now, remember I told you those people in Austin sometimes don't know many things? Okay. On the test, they might use mechanical energy and kinetic energy interchangeably. But we're smarter than that. We know they don't mean the same thing. But, since you have to take the test that they make, they will use mechanical and kinetic energy as the same thing, as synonyms. So use those two things as synonyms. So on the test, if you're looking for, because you know it should be mechanical, not kinetic. If you're looking for the word mechanical and you can't find it, but the word is kinetic is in there, that's the right answer. Okay? So they use mechanical and kinetic energy interchangeably because they figure, well, mechanical energy is energy of anything that is moving, and kinetic energy is energy in motion. So they use those as the same thing.
Right.
Right there on number 2, you know how you have like, there's nothing on the right side? Or is it worse right on it? Or
That's why I'm talking.
Oh,
Yeah.
okay, good.
Yes.
So
Yes.
For definition, we put any form of movement.
Because, yes, it is. Anything that is moving is considered mechanical energy. So, we're talking about water, like I'm talking about a hydroelectric plant. A hydroelectric plant is a plant that makes electricity because of a water moving. Like, for example, the Hoover Dam is a hydroelectric plant. Okay, water's rushing through, it moves rotors, those rotors move generators, generators make electricity. So that water flowing through is mechanical energy. Windmills,
Yeah.
same thing. The air is moving the blades, that is mechanical energy. The air moving is mechanical energy. Okay, so anytime you have anything moving, it's going to be considered mechanical. Yes,
Like
Jesus.
from back a long time ago, they used the big old wheels to power up the
Yes,
factory.
those big wheels, the same thing. And what it was is that those wheels had like just basically resistance, and as the water moved, it would move the big wheel, and it was the same thing. So technically, a dam was the dams that we have now, the hydroelectric plants, are a more recent technology upgrade to those big wheels.
Okay.
Okay. Yes. Yes.
When you have a hydroelectric, like water that like you guys, when the water comes in and like the water, it is still mechanical until it goes to the generator.
Yes. Yeah. Anytime you have any type of movement, like those wheels moving, the rotor moving, blade moving, any of that is going to be considered mechanical. does not turn electrical until the generator actually makes the electricity. So going into the generator is mechanical, coming out of the generator is electrical.
I want to call it like in between both of those two. Like where, never mind.
That is a transformation. So, I mean, there's nothing in between. It's like you're moving and the moving makes the electricity.
Okay.
Okay. Alright, then we come to chemical energy. Chemical energy is energy that is stored in the bonds of molecules, of any type of chemical. Okay? Now when it comes to chemical energy, these are the things that you need to remember. Fuels. Any type of fuel. Petroleum, natural gas, fossil fuels, gasoline. Any type of fuel is going to be chemical energy. Okay? Batteries. Inside a battery, there is a chemical in it. Okay? It's chemical energy. If they talk about any type of food, food is chemical energy. So when you go to lunch and you're eating chemical energy. You're going to turn that chemical energy into mechanical, hopefully, when you get to class and actually do some work. Okay? And then the last one they'll talk about is in like plants, photosynthesis. Because photosynthesis is really taking solar energy and transforming it into chemical energy. And it does it because the solar energy is being stored in C6H12O6, which is glucose, which is a chemical. So that energy is being stored in that chemical. That's why it's basically making chemical energy, because it's making the food for the plant. Okay? So, for chemical energy, it's energy stored in bonds, and you need to remember any type of fuel, okay, photosynthesis, food, and batteries. Those are the things that they might put on that test to make, and you need to make sure that those are examples of chemical energy. Okay? Solar radiant energy basically is light energy. It's coming from the sun, or it could be coming from a light bulb. Obviously, it is the major source, or the main source of our energy. Our original source of all the energy here on Earth, for the most part, not all of it, but for the most part, is the sun, right? The sun's energy is our original source of energy for mostly everything. There are a few other types of energy that actually come from within the core, but we're not going to discuss those. We're just going to talk about solar energy. The reason for it is because that's basically our major source of energy. Now, a lot of times these two are used interchangeably. And the reason for it is because it's really light energy and it's moving exactly the same way. But a lot of times when you see solar and radiant, they tend to think of just the sun. And then when you see light energy, they're thinking of like a light bulb or something. But technically, they're all the same energy. It's light waves. Even the sun's rays, those are still light waves. You have thermal energy, which is basically almost like heat energy. Now, with thermal energy and heat energy, those will be used interchangeably. So if you're looking for the word thermal and you see the word heat, same thing. If you're looking for the word heat and you see the word thermal, same thing. So thermal and heat used interchangeably. I have nuclear energy, which is the energy inside of the nucleus. Now remember that when we talked about the atom, what's inside the nucleus?
Protons and neutrons.
Protons and neutrons, right? And what charge are protons?
Positive.
And they're all positive, right? And what do like charges do? If I have two positive ends of a magnet, what are they going to do? Are they going to attract or are they going to repel? Repel. The protons are all stuck in the middle. Why are all the positive charges not repelling? Because of the nuclear energy that's in there. There's something called a strong nuclear force. A force, an energy that is taking all that stuff in the center, the nucleus, and sticks it together. Okay? Now, that's a lot of energy. I mean, just think about it. Think of you taking two magnets and trying to put the two like charges together. It takes some force for you to do that. Now, think of cesium, who has 55 protons. All those protons are being stuck together with this force and this energy. Nuclear energy is the energy that we get from the splitting of an atom. Okay? Atomic bomb, that's actually what's happening, is they're taking an atom and splitting it in half. Now, how is that happening? Well, it happens because the nuclear reactor basically takes atoms and they make them collide with so much force that it allows that force to overcome the strong nuclear force, which splits it in half, allows all that other energy to be given off and be used. So, like, if you ever seen nuclear plants, have you ever seen those that look like, it looks like a big cone? Okay, there's usually
Yeah.
pictures.
Like
Okay,
holes.
those are nuclear plants. Okay, and basically, yeah, like in the Simpsons, you've seen those, right?
With the little talkie sound?
Yes. All right. So the Simpsons, you've seen those, right?
Yeah,
Nuclear plants. Okay. All right. So what's happening is in those plants is they're taking radioactive material. They're taking atoms, splitting those, getting that energy out. That energy moves rotors, goes through a generator, and makes electricity. Okay? It is the fastest and most efficient way to make electricity is a nuclear plant.
But is it?
Unfortunately,
It's not safe.
it's not safe because you have the radioactive waste, which is bathrooms. So it would be safe if everything works exactly like it should, but sometimes, unfortunately, things happen, such as the meltdown in Japan, Chernobyl, okay, is when the plant, for one reason or another, something goes wrong and the radioactive material is able to leak out. Yes.
So what happens? What is it that's bad? The radioactive. What is it bad? Like, what does it do to us?
Well,
It
any
just-
type of
just kill us?
radioactivity, basically what it does, it changes, it messes with your genes, it messes with your DNA. You
So
end up
just-
getting radioactive sickness, which basically it starts killing off your cells. Radioactivity kills off your cells.
Oh. it
That's
just-
why people have cancer, they go through radioactive therapy, is because what they're doing is they're actually putting radioactivity into their body, so the radioactivity kills off cancer cells. Now, unfortunately, it doesn't just kill off cancer cells, it kills off healthy cells. That's why they lose their hair, that's why they get sick. Because the medicine they're taking is not just medicine
For
to kill off cancer, unfortunately it also kills off healthy cells too. And that's why they get, sick right after the
Oh,
treatment.
okay.
Yes, yes.
Say if you went to a radioactive place and they left, would you still be sick? Would you still have radioactivity?
It depends on the levels. If it's a low enough level, then it should be okay. Now, if it's a high enough level, you would get sick right then and there. Have you seen the movie Chernobyl, the Chernobyl Diaries?
Yeah.
Okay. One of the things that the guy says is that you can't take something from that area because it's contaminated. Okay? So if it's there long enough, then yes, your body will start absorbing that radioactivity. If you take something from an area that has radioactivity in it, then that thing, whatever you take, has radioactivity. It has the isotopes there. So whenever you take it out, your body is going to absorb that, so you can still get sick later
So
on.
even though you've been there for a few minutes or
It depends on the level. Obviously, the higher the level, the easier it is for you to get sick. Yes. Yes.
That strong force you were talking about, is that one of the four forces?
One of the four forces.
Yeah, like gravity, magnetism.
Yes. Strong. It's basically on its own. Yeah. That force completely on its own. Yes.
And when nuclear bombs come, how do they do? They just split one atom?
No. It's open.
They split them all at once?
I would imagine so, because, I mean, for the amount of energy that an atomic bomb gives off, it's several.
Not just
I mean,
one,
it's
it's
several. It's not
several.
just gonna be one atom that's gonna do that big of a damage.
But how does it do it? Does like when it collides, does it split then?
I really couldn't tell you. I've never seen the inside mechanism of an atomic bomb, but I'm sure you can look that up and find all sorts of things. It's a little scary to me, so I'd rather not know.
Well, Albert Einstein was studying.
Yeah, I mean, basically, I mean, I'm sure you can link that up and just look at the mechanism of an atomic bomb, and it'll give you in detail what's actually happening
Yeah,
inside the
if you
bomb.
think about it, it's a little bit of matter, change it to this humongous thing of energy.
So it has a good amount of whatever radioactive element that they use, be it plutonium or any of those radioactive elements. Whatever one they use, it's gonna have a good amount in there. Uranium, plutonium are the two that are the big ones that I've heard that are used for things like that. Yeah. All right, and then the last one is sound, which is just basically energy traveling through air or a table or a liquid, basically through matter, that makes vibrations that you can hear. Now, as I said, these are the different types. Now, they're not just going to come and say, okay, so what's nuclear energy? No. They're going to say, so, in a nuclear plant, they're creating electricity through step 1, step 2, step 3, step 4. And that electricity runs through the wires that goes to a house that has a heater that turns on. And they're going to ask you, what were the steps? What are the transformations? So you're going to have to think, okay, so it's a nuclear plant, so nuclear energy's first. Okay? Then that nuclear energy changes energy that basically moves air or moves a rotor or moves something. So that nuclear energy is turned into mechanical energy. And that mechanical energy is turning the rotors inside the generator. So that mechanical energy has now turned into electrical energy in the generator. That electricity is run through wires. Still electrical energy. Okay? It goes into a house and it turns on the heater. So now that electrical energy turned into thermal energy. Maybe even light, because you know some heaters actually have a light that turns on, right? So now that electrical energy turned into thermal energy and light energy. That is the type of question you're going to get asked. They're going to give you maybe a picture and say what's happening in step 3, and you need to know the transformation. So you have to know these different types to be able to see what is happening in each of the steps in the picture. Okay? Now, we did have an activity in which we were going to look at several transformations, but we can't find the little thing that we need to do. So we're going to do it tomorrow. So this page right here, just put it over to the side. Let's use,